0. First and second order reactions. Don't forget the test. See you next week.
Hey, Danny.
Hey Samir. I forgot my notebook. What are you doing here? I am lost with this course. I don't understand most of the lectures. I don't know what I have to do.
I have free time now. Let me help you.
Really? Thanks.
Okay, let's start. First of all, chemical reactions vary greatly in the speed at which they occur. Some are essentially instantaneous, as the explosion, while others may take years, as rusting. The reaction rate for a given chemical reaction is the measure of how quickly the reactants in a reaction change into the products of the reaction. There are many ways to measuring the reaction rate. One of them is using the reaction rate law.
So, what is the reaction rate law?
Is an expression which relates the rate of the reaction to the rate constant and the concentrations of the reactants. The exponent is known as the order of the reaction with respect to that substance, where the overall order of the reaction is found by adding the individual orders. The reaction order is the relationship between the concentrations of species and the rate of the reaction, which can only be determined experimentally. Chemical reactions are often classified as zero-order, first-order, and second-order reactions. Let me start with zero-order reaction. The zero-order reaction. It is when the overall order of reaction is equal to zero. The rate of zero reaction is independent of the concentration of the reactant. For the zero-order reaction, we write the differential rate law that shows how the rate of a reaction depends on concentrations. Then, the integrated rate law that shows how the concentrations of species in the reaction depend on time. Start with the general rate law equation. Then, write n equals 0. Finally, we take the integration. The equation can be represented graphically. The first-order reaction. It is a reaction when the overall order of the reaction is equal to 1, and it depends on the concentration of only one reactant. For the first-order reaction, we write the differential rate law that shows how the rate of a reaction depends on concentrations. Then, the integrated rate law that shows how the concentrations of species in the reaction depend on time. To get the integrated rate law, first, we must write the differential form of the rate law. Then we rearrange it. Finally, we take the integration. This can further be arranged into linear equation form. Also, to create another form of the rate law, raise each side of the previous equation to the exponent, e. The equation can be represented graphically. The second-order reaction is when the overall order of the reaction is equal to 2. Let us consider the simple reaction here. Then the rate will be. In the second-order reaction there is two cases. First is the identical reactant, and the second is the different reactant. Identical reactant is when you have the same reactant. The rate will be. To get the integrated rate law, first, we must write the differential form of the rate law. Then, we take the integration. Finally, we get the linear equation. The different reactant, the rate of the reaction will be. To get the integrated rate law, the same thing done in the identical reactant. But first we have to understand what is happening inside the reaction. So the first step is write it in differential form. The second step, we integrate it by using partial fraction method. Finally we get. Then just rearrange it. I hope everything was clear.
Thank you so much for that. I appreciate your help.
Welcome.